Today we're going to look at surds and a lot of the different rules, and similar to like laws of indices, there are laws of surds as well. So we're going to look at how we simplify, how we multiply bits together, can we add them, how do we simplify a surd. We're going to go through all of that stuff today. So we're going to start with multiplying and dividing surds. So much like algebra, when you are collecting terms or adding terms, you have to be careful and make sure you only add terms that are the same. Same rule applies for surds, and we'll look at that in a few examples. But you can multiply an x and a y together. You can't add them together, but you can multiply them. And the same thing applies for surds. As long as the numbers are inside the surd, you can multiply them together. So the square root of 3 times by the square root of 7, you can multiply those two things together and it just becomes the square root of 21. As long as the numbers are both inside of the surd, then you can multiply them together. And the same for division. So we can do the square root of 24 divided by the square root of 6. They're both inside the surd, so we can divide them. 24 divided by 6 is the square root of 4, which actually 4 is a square number, so we can just write that as 2. Don't forget to do that, okay? So if you are square rooting something that is actually a square number, then you don't need to leave it in surd form. You don't need to leave it with the square root. You can actually calculate the square root. So the square root of 4 is 2. So we write it as 2 and not the square root of 4. Now this next example starts to get a little bit more complicated. We have the numbers inside the surd, but we also have some numbers outside the surd. And again, just like you would do with algebra, if you were multiplying 2x by 3y, you'd multiply the 2 and the 3 and that would give you 6. And you'd multiply the x and the y and that would give you xy. Same thing applies here. So we multiply the numbers outside of the surd. So we multiply the 2 and the 3. That gives you 6. And then you multiply the numbers inside the surd. So 3 times 5 is 15. Okay, I hope that's making sense, straightforward enough, and it's the same thing for division. So here we have 10 and 2, which are outside of the surd, so 10 divided by 2 is 5, and then the numbers inside the surd, the square root of 8 divided by the square root of 2 gives you square root of 4 again. They like that one. So again, make sure you work that out. The 5 is multiplied by the square root of 4. The square root of 4 is 2. So it's 5 times 2, which is 10. Okay, so watch out for those square numbers that will actually square root, and you don't need to leave them as a surd. Okay, so the next step then is to be able to simplify a surd. And what that means is you are looking for a factor of whatever number is in your surd. You're looking for a factor that is a square number. And we can then take that outside of the square root and leave whatever whatever can't be square rooted inside of it. Okay, so I know that 75 is 25 times by 3. So I am going to rewrite my surd. I'm going to keep it all underneath the same one, is 25 times by 3. I can then split that into 2. So I can split that into root 25, root 3. Okay, they're still multiplied together. They're both still square rooted, but I've split them now into 2 square roots because 25 is a square number. The square root of 25 is 5. 3 isn't a square number, so that stays as a surd, but this is now the simplified form of root 75. It is essential that you know your square numbers, okay? Sometimes, especially if I'm getting into using bigger square numbers, I might write them out at the side so I know 1 times 1 is 1, and then 4, and then 9, 16, 25, 36, 49, and so on, okay? Write your square numbers out at the side of the page so you can just check what number you're trying to simplify, which of the square numbers is a factor. Check you're taking the biggest factor out as well, okay? Just like when you are simplifying anything, if you're factorising a bracket or something like that, you always use the biggest factor that you possibly can. So for 32 is actually a good example of this. So the square root of 32, we need to find a factor, a square number factor of 32. Now 32 will divide by 4. Yeah, 4 times 8 makes 32. But that wouldn't be the biggest factor, the biggest square factor, because 16 also divides into 32. So we're going to choose 16 because that's the bigger one. We want the biggest square factor. Okay, so I'm going to rewrite 32 as 16 multiplied by 2. I'm going to split it into 2 roots. So I have the square root of 16, the square root of 2, and then I know the square root of 16 is 4, and then the 2 can't be square rooted, so it stays in the surd. And that is the simplified form of the square root of 32. The last one is the square root of 8. The only square number that will divide into 8 is 4. So we rewrite it as the square root of 4 times by 2. And then we rewrite it as root 4, root 2. And then we actually square root 4, which is 2. And the other 2 has to stay inside of the surd because 2 isn't a square number. It can't be square rooted. And again, now we have simplified the square root of 8. So that's simplifying. As long as you know your square numbers and you can find factors of another number, you will be able to answer these questions, okay? And like I say, write out your square numbers in a list at kind of the side of the page for your working out if that helps you. The last thing then that we're going to look at today, there's a lot more on surds, but we will do those in a separate video. The last thing we're going to do today is look at how you can add surds. Okay, so just like I said at the beginning of the video, you can multiply any surd together that you want. But when it comes to adding them, you can only add like surds together. So same as if we had 2x add 3x, we can add that together to make 5x. If we had 2x add 3y, there's nothing we can do. We can't add those together because they're different terms. The same rule applies to surds. We can only add together like surds. So at the minute, they're not the same. We have the square root of 50 and the square root of 32. They're not the same. They're not like. So we can't add them up yet. What we do need to do is simplify the surds. So I'm going to rewrite both of them. So the square root of 50, if I write out my square numbers, I've got 1, 4, 16, 25, 36. I've missed one out. Oh, that's embarrassing. I missed out 9. 1, 4, 9, 16, 25, 36, 49, so on, so on. 50 will divide by 25. So 50 is the square root of 50 is the same as the square root of 25 times by 2. And 32, as we did on the last slide, 32 is 16 times by 2. Okay, so we split the surds up. We've got root 25, root 2, plus root 16, root 2. Square root the numbers that are actually squares. So root 25 becomes 5. 2 can't be square rooted, so it stays in the root. Root 16 is 4. And again, the 2 stays inside the square root. Now we have like surds. We have root 2 and root 2. We've got 5 root 2 plus 4 root 2, which makes 5 add 4 is 9. So 9 root 2 altogether. Again, just like you would do with algebra, if you had 5x add 4x, it's 9x. You just add together the amount of x you have. Nothing else happens to the x. It doesn't become squared or anything like that. It's still just the amount of x that you have. Okay, let's try again for root 80 plus 20 then. So root 80 is 16 times by 5. Okay, 16 goes into 80 5 times. So we can rewrite it like that. 20 is 4 times by 5. 4 is our square number. Times by 5. split them up. So we've got root 16, root 5, plus root 4, root 5. And now do the square roots. So we can square root 16 to get 4 root 5, and we can square root 4 to get 2 root 5. And now that we have like terms, they're both root 5, we can add that together. So root 4 root 5 plus 2 root 5 is 6 root 5. Nice and easy. Okay, the difficult part is doing this, is simplifying the surd. Once you've got the same surd in both, it's just adding them up. It's just adding them together. One last example then before we finish this video. This one is only more complicated because of this 3. You have to remember to key mistakes, or the mistakes that I see most often are people forgetting that 3's there. Okay, so we just need to keep it in mind as we simplify the surds. So I'm going to start off the same. So I'm keeping the 3 there. I'm going to break 12 up into 4 times by 3. 4 is our square number, and it goes into 12 3 times. 75, again, as we did on the last side, 75 is 25 multiplied by 3. And now we can start to simplify it. So we've got 3 lots of root 4 root 3 plus root 25 root 3. Now, this is the bit where you have to remember that 3's there. The square root of 4 is 2. Okay, I'm just going to write it underneath just so we don't forget. That's 2. The square root of 4 is 2. We have 3 lots of that. So actually, we have 6. Because that 4 has become 2, we have to remember to multiply it. The root 4 has become 2. We have to remember to multiply it by this 3. Okay, 3 times 2 is 6 root 3. Okay, so be really, really aware that 3 is there and that you have to multiply it by whatever the square root of 4 is, which is 2. And then the second one, there's no number to worry about. We just need to square root 25, which is 5. And again, it's root 3. So now we have like surds. We can add them together. And you get 6 add 5 is 11 root 3 altogether. And that is your final answer. Okay, so we've gone through a few things there. You have multiplied and divided surds. So remember, as long as the numbers are inside surds, you can multiply them or divide them. And that's straightforward. To simplify a surd, you find a square number factor. You split it into 2 roots. You square root the square number and leave the other number inside the surd because it can't be square rooted. And then you have to use simplifying surds to be able to add surds that are not like, that are unlike together. You can only add surds that are the same. So you can only add a root 2 with another root 2, or a root 5 with another root 5. You cannot add surds that are different together. If you have a question where the surds are different, you're being asked to add them, you will have to simplify them first. And they will always give you the same surd in each term, so that you can actually add them together and simplify it. Okay, I hope that makes sense. Again, we will do more work on surds. This is not all of the content that you need. We will do rationalising the denominator. We will look at expanding brackets with surds, because those are all kind of extra things. But these are the basics. If you can become confident with these things, you will find the next steps a lot more straightforward. Okay, I hope it helped. Thank you for listening.